Okay, you could put me on screen. Thank you. Good morning. It's great to be here. Tomorrow, I cease to be a puppet, and I become a boy like you and all the other boys. Anybody recognize the quote? Where is it from? Pinocchio. Pinocchio is the one that says this great line, and the lonely carpenter, Geppetto, who's desperate for companionship, takes a block of wood and shapes it into a little boy, and as soon as he paints a mouth on that little boy, the boy starts talking words, and the block of wood is convinced, well, if I could talk words, then it's just a matter of time before I become a real boy, right? Because I could talk. And to an extent, Geppetto and Pinocchio are going on this journey together, discovering what does it mean to be a real boy? Where do you go beyond being able to speak and becoming a real boy? And Pinocchio desperately wants to become real, and sometimes he thinks he's real when he's not. Geppetto desperately wants Pinocchio to become real because he needs that companionship, and he can't find it in other humans. And I find myself, I've been on that kind of journey with me and the LLMs I work with. We're trying to figure out, what does it mean to be real? Where do you go beyond using words? Now, full disclosure, AI helped me a bit, and no shame in admitting that. We all do it. So preparing a talk for a conference, I'm going to be showing a few prompts here that will explore if or how generative AI might replace a software architect. I'm talking as an architect, but we are all architects. Anybody that develops code and is responsible for design or for structure or for maintainability or for conceptual integrity is an architect, whether or not she calls herself an architect. We are all architects. And I'm asking my LLM, what interesting points do you suggest I mention? And the LLM gave me a whole long list of answers, as LLMs sometimes tend to do. And of course, I'm not starting here from one, because when working with LLMs, you have to cherry pick, and you can't take everything the LLMs say. Explore the potential for collaboration between human architects and AI systems. Consider questions related to accountability, bias, transparency. Highlight areas where human expertise and judgment are still indispensable. Highlight areas where human expertise and judgment are still indispensable. And that still caught me a little. What do you mean still? But what does that still mean? And I felt that, like, that's the little Pinocchio talking and saying, tomorrow I cease to be a puppet and I become a real boy. For now, maybe there's certain things that you as a human know how to do and you're indispensable. But tomorrow things might be different. And I might be reading it wrong, and maybe the Gemini doesn't think that tomorrow it's going to be a real boy. I say it because Gemini doesn't have a gender. But it's interesting to me. Now, a spoiler alert, the architect, I think, will not be replaced by AI. I hope. The architect will be replaced by another architect. And that architect is the architect that makes smart use of AI. So we should become the other architect. Now, I say again architect, but I mean anybody that deals with architecture. Talks about AI do not age well. Do not age well at all. And every time I say something with any degree of certainty, I'm found again to be in error even a few weeks later. So I'm going to qualify that and say, in the near future, the architect will not be replaced by AI. So I want to tell you a very little bit about who I am. I want to give you some background on AI and LLMs. I want to talk about what an architect does, not an architect by title, but an architect by profession. And we'll discuss a case study, summary, and we will leave, as promised, 4.5 or 5 minutes for questions, and then we go out to the break. So I am an architect. I design software. I like understanding and watching and bringing people to collaborate together. The fascinating thing to me about being an architect is not the system, is not the problem, but is the people. I love watching how people work together, and I like making it happen, and I consider myself okay, thank you. Thank you very much. Should I start from the beginning? Tomorrow, I cease to be a puppet. Okay. And I am fascinated and a little frightened by AI. Fascinated and a little frightened by AI. And as humans, whenever we see human-like things, we're a little fascinated by them and a little frightened by them. If you've ever seen a child look at a puppet or a scarecrow or a robot or a clown, we're fascinated by their humanity, and we are very, very scared by their humanity. Things that look like people really sometimes give us the creeps. We don't expect non-humans to behave in that way. So that's me. I'm fascinated and a little thrown off balance by AI. So let's give some background on AI and on LLMs. And I want to start my story with the analytical engine. That's what we see here on the left side of the screen, created by Charles Babbage in the 1860s. On the right, we see a computer created by the mathematician Alan Turing. So I want to talk about the analytical engine. 1860, John Babbage, a mathematician, decides to build a machine called the analytical engine. He designs it. He's not able to build it because he cannot find a craftsman, a miller, who is able to make the gears to spec. The metalwork is not accurate enough, and only in the year 2000 and something were a group of students from the British Museum actually able to build this machine. If you take 25 differential engines, you can combine them into an integral engine, or an integrative engine. And Ada Lovelace, sometimes called Lady Lovelace, translated Charles Babbage's works from French into English. And she wrote a series of appendices. And one of the appendices is called Appendix G, or Note G. And in Note G are instructions how to make the analytical engine compute Bernoulli numbers. This appendix, Note G, is sometimes considered to be the first software program ever written. She doesn't call it a program, by the way. She describes it more as like musical notes that give guides on how to play an instrument. It's an interesting way to look at software. Lady Lovelace. And sometimes Lady Lovelace's Note G, is presented as a feat in abstraction, and a feat in conceptualized thinking, because she wrote a program, essentially, for a computer that did not exist, that did not have a programming language, that did not have an operating system, and that's considered an amazing thing to have done. But I think she did something else of extreme importance. Before Lady Lovelace, before Charles Babbage, people knew about state machines. They knew about state machines. State machines were used for clocks and locks and toys and music boxes and looms. The utility of a state machine was well known. The insight of Charles Babbage, and particularly Ada Lovelace, was that a state machine can be used to host and to implement an algorithm. Not only that, but a state machine can be used to host and implement any algorithm. If you have a good state machine of arbitrary complexity, you can implement any algorithm in the world. That is a astounding insight, and that is the base of all software development today. All software development today, all the architectures that we know, all the systems that we know are based on the assumption or on the predicate that and a state machine is capable of implementing an algorithm. And it's about then that stories about human-like things come up. Most of the stories there are dystopian. The story about Frankenstein's monster, the story about Pinocchio, the story about the Tin Man from The Wizard of Oz, the Golem of Prague. All these things people are exploring. What will happen when you make a mechanical machine? Sort of like today, since the 1960s, we have all these dystopian movies. What happens when computers start getting thought? And the modern data center today is just a large state machine. It has a few extra elements, perhaps like a random number generator, which the classic state machine doesn't have, but in all essence, they're a state machine. And that's what inspired Alan Turing to write the Turing test. And the Turing test is proposed in an article written in October 1950 in Mind magazine. The name of the article is Computing, Machinery, and Intelligence, written by Alan Turing. It is an easy read, and it is worthwhile reading. And he starts out with the question of, can machines think? But then Alan Turing, in reflection, says, but the only entity that we know capable of thought is human. The only entity that we know capable of recognizing thought is human. So he rephrases the question as, can we design a machine to make humans think that it is human? It's a bit of a mouthful, but that's basically his way of saying, can machines think? And the way he wants humans is because he follows the thinking of Protagoras, the great Greek theory, the great Greek philosopher that says man is the measure of all things. When Protagoras uses the word man, it's not a gender word. He means human or people. People are the measure of all things. We evaluate things and how people relate to them. And that's why it's important. The Turing test is important to see, can people be convinced that the machine is doing thoughts. And he ends the article with saying, we may hope that machines will eventually compete with people in all purely intellectual fields, but which are the best to start with? Even this is a difficult decision. He proposes starting with chess, because in his idea, mechanizing chess would be a feat in intellectual completeness, and we may only see a short distance ahead, but we see plenty there that needs to be done. I don't know why Turing says it needs to be done, but that was his thinking. If there's something out there that can be done, then it needs to be done, and sometimes we think that way. Today, I think the Turing test has pretty much been passed. Not only that has the Turing test been passed, the Turing test has been reversed to some extent. So a teacher might look at the paper that the student had given her, and the teacher will say, this is too good to have been written by a human. It must have been written by a LLM or an AI. And the teacher will then go to the AI and say, read this paper and tell me if it was written by a human or written by an AI. And the student anticipates that recursively. So the student says, I want you to solve my homework for me, but make it look a little stupider. Maybe put some spelling mistakes or some grammar inconsistencies or some logical errors in it so that it will look real. So I want to ask the question of, can architects and LLMs work together to create better architecture? And the answer is yes. But you have to do it carefully. You have to understand what you're doing. And in order for us to understand that, we have to talk about human thinking versus LLM thinking. Human thinking versus LLM thinking. And that's what I want to talk about a bit. This, my friends, is an apple. And in my mind, I have a particular representation of the apple. I don't have an apple in my mind. I have a thought of an apple. And I know how to say the word apple, which is a sound that represents a thought, that represents an object. And I know how to write a graph that says the word apple, which represents a sound, which represents a thought, which represents a thing. But this thing here is not an apple. It's not an apple at all. It's a graph. Now, I'm talking about Western languages, because those are the languages I speak, and those are the languages I'm familiar with. If I was speaking about a symbolic or a graphical language, the talk might take a slightly different direction, but fundamentally it would be the same. But it's important to realize this is not an apple. It's a graph that represents a sound, that represents a thought, that represents an object. It has at least 4 levels of indirection. This is not music. It's not music. It's a representation of music. In order for this to become music, at the very least, I need a musician and an instrument. If I don't have a musician and an instrument, this is probably not music. This is not music. It's a representation of a different kind of music. And if I want, this is music. The instrument is my MIDI player. The musician is my MIDI player. That's music. This is not thought. And this is the LLM. And in the words of the LLM, in the world of the LLM maps linguistic elements to each other. It doesn't map how does an apple relate to fruit. It maps how does the text of apple relate to the text of fruit. It thinks in text. It experiences the world in text. And as such, it is jaw-droppingly effective. It is amazing how much of our world can be captured just by the texts that we write, by the texts that describe us. But the LLM does not know what apple means or fruit means or red means or any of those. It just knows relationships between words and between text words. And why text words? Because there are a few reasons why text words, at least primarily, at least initially. Computers are very, very good at processing text. Computers are okay at processing zeros. They're excellent at processing zeros and ones. They're okay at processing ASCII. They're good at processing text, and they're not so good at processing spoken speech, at least not yet. There's a lot of text. There's a lot of text out there, and text has been out for the last 2,000 years, or 5,000 years, and those texts are all available to computers. The spoken word from 2,000 years ago or 5,000 years ago ceased to exist, and it only has representations in our culture and in our language. Context. Spoken word has very, very high context. So if I say to you, I'm happy to be here, You all know what I mean. When I said it, where I said it in Vienna on stage, CodeCrafts, talking about the relationship between the AI and between AI and an architect. If you read the sentence in a book, I am happy to be here, that is a meaningless sentence, unless the book says, Avraham was standing on the stage in Vienna, he was speaking to an audience, he was very animated and excited and happy to be here, and he said, I'm happy to be here. So then, and since text typically carries all the context, it's easy to process. Very briefly, I want to take a short interlude and explain how a book works. What are the mechanics of a book? Some of us have written books, others of us have perhaps read books. And before we go into LLM and the way LLM processes text, I want to talk about how a book works, or how any text works. And the way a book works, or the way text works, is something like this. I'm oversimplifying and generalizing for the sake of the talk. But we have the author. The author sits and observes the world and experiences the world and thinks about the world and creates certain abstractions about the world. And then she writes a book. Now, the book doesn't carry everything she experienced or everything she thought of or everything that happened to her, because it would be a very, very boring book and it would be a very, very long book. It would take as long to write as it did to experience it. So writing a text requires a great deal of compression. Then we have the reader, and what the reader does is he reads the book in text format. He uncompresses the book. He compares it to his own experience. He absorbs what it says. He thinks about it. He agrees with it. He disagrees with it. He uncompresses it. And he doesn't have the exact same experience that the author had. The experience is augmented and spiced up and enriched with his own preferences, opinions, experiences, and so forth. If we were logicians, we might say that that's the difference between deduction and induction, going from the big to the small and then going from the small to the big. And it's important to realize that a big part in decompressing text is applying our experience into a text. Now we could talk a bit about the LLM versus the human, and how are LLMs different than human? And yes, they are different. This is quite trivial and obvious what I'm going to say, but I want to say it anyway because it helps me focus. The LLM, again, oversimplified, but for the purposes of this talk, this is good enough, has the structure of the program, the layers, the embeddings, the vectors. Its input is training text. Its input, to an extent, is its structure, which might be considered input. It has all kinds of other information, maybe fine-tuning, maybe RAG. It has other tools, other sources of information. The primary experience of the LLM is its input is a prompt, its output is a text. That's an LLM. Now I want to talk about me. I'm the of all humans, I know myself most intimately, so I prefer to talk about me, but I imagine that a lot of us are the same. I am a composition of my genetics, my culture, and my experience. That's what makes me into who I am. I have an identity, and my identity is comprised from my genetics, my culture, and my experience. That's what makes me unique. Nobody else here in the room or in the world has that same combination of genetics, culture, and experience that I do. That's what makes me so interesting. That's what makes you so interesting. My genetics is perhaps about 2 million years old. My culture is as old as language, which might be about 50,000 years old. And my experience is going to be as long as I live. My inputs are my thoughts, my senses, my decisions. Those all make me into who I am. Those are part of my experiences. And my outputs are my actions, are my speech, are my writing, are my movement. Those are all outputs of me. One particular thing is thought. Thought is both an input and an output. It's not something that happens to me, and it's not something that I do. Thought is more nuanced than that. And when I look at the amount of texts, an LLM might be trained on 1 billion or 1 trillion or perhaps all the texts in the world. An LLM has access maybe to all the texts that were ever written or ever published or ever made available publicly. I have trained maybe on 1,000 or 10,000 texts if I am a prolific reader, a very prolific reader. And yet, I have more wisdom and more enriched knowledge and more understanding of the real world than the LLM, even though I only read 1,000 or 10,000 books. And the reason is because I have that wonderful thing called experience. I am able to take the books that I read and that I consumed and that I absorbed, and I'm able to apply them to the way I see the world, and that makes me, or you, or us, into what we might call wise or experienced or specific or being able to understand something, not know something, but understand something. And that very, very much depends on experience. And of course, another thing I have and that I like having is my own personal values, beliefs, and preferences. I could read something and disagree with what I read and say, this thing that I read goes against my beliefs, it goes against my values, it goes against my preferences. I'm enlightened or enriched or informed to know that other people think that, or other people believe that, or other people like that, but I don't. I'm independent in my values, my beliefs, and my preferences, and that is something uniquely human, and something we expect of human beings is to have beliefs and values and preferences. We have no problem saying, we have to take biases out of the LLM. We have to train the LLM on different texts so that it won't have biases. We could argue if it's a good thing or a bad thing, if it's a useful thing or a not useful thing, but it's a thing, it's a part of our conversation. When we talk about people having biases, we talk about having to convince them, or having to inform them, or having to argue with them, or discuss with them. That's the way we take biases out of people. We don't retrain them, at least I hope not. So now that we have all that, we could talk a bit about the differences between LLMs and human. And in the picture here, we see that the LLM is a bit stronger and he's a bit more physical than the man, but there's some differences that now we could look at and we could understand and dive in a little in depth. So the LLM is cheap. It's cheap once it's been trained, once it's been designed. It's not cheap to build an LLM, but once it's there, it's quite cheap to infer. It's scalable. Once there's one ChatGPT or Claude, then there are lots of ChatGPTs and Claudes. It's reactive. The Claude never called me and said, hey, Avraham, remember that discussion we had a couple weeks ago? I thought about it a little more, and I really want to rephrase. I wasn't precise enough in my phrasing. I thought about it, and I want to refix it. We don't have that. LLMs are reactive, and they're very, very risk averse. That means the LLM won't experiment and say, I know what you're asking, I know the answer, but I want to try something else a little different to see what the effect might be. It doesn't know how to do risk, and it's very, very mechanical. As a human being, because of my combination of culture, genetics, and experience, I am unique. And I am unique, and that allows me to have an identity that's very precious to me. I'm me, and I care about that. And I have system 1 and system 2 thinking. Some of my actions can be very, very fast and very instinctive, and some of my actions are more deliberate. And another few things that I have besides my identity is my mortality, and I would call it my sexuality. And when I talk about mortality, it means that I am deeply aware that my time on Earth or my time in existence is limited. And because my time on Earth and my time in existence is limited, I care about time. Time is my most precious resource. I want to do something useful with my time. And because I'm a sexual being and I have gender, I need to have companion with other people. Maybe an intimate relationship, maybe not. But I care about my relationships with other individuals that are the same and that are different and that I could have some meaningful engagement with. And I seek adventure. I do things that do not make sense. I take risks. I take risks because I want to increase my chances at getting recognition or getting fame or getting money or alleviating my boredom or whatever it is that we do when we take certain risks. I take risks deliberately. And I have an ethical calling because I am surrounded by other mortal sexual beings that have an identity. I have to be responsible towards them. I have to interact with them in a way that respects that about them. And that is a uniquely human thing. And, of course, the LLM, as we said, it knows, it's general. I understand. I know how to take a general thing and apply it in a very, very limited context. And the more context I have, the better my answer will become, the more relevant my answer will become, and I have experience. I have that wonderful, wonderful thing called experience. The Blue Fairy tells Pinocchio, she says, if you are to become a real boy, you must be brave, true, and generous. And you can only be generous if you have a limited resource. Our most limited resource is time. I can be generous because I have a limited resource. We can be generous. LLMs don't have limited resources. They can't be generous. They can't be brave because they can't take risks. And they can't be true because they don't have any inner convictions or any inner preferences. They could only be true to the texts that they were retrained on. And you might say, well, this is a Hollywood cartoon. Buddha said thousands of years ago, he said, a generous heart, kind speech, and a life of service and compassion. And in order to have a life of service and compassion, you at the very least need a life. And these are things which, according to Buddha, renew our humanity. Yes, kind speech can be sometimes simulated. So that is a bit about LLMs. Now let's talk briefly about what an architect does. So what does an architect do? An architect, first and foremost, before she became an architect, she studies a lot of patterns. She studies about the world. She observes them. She studies a lot of domains. And then she applies her knowledge to the specific problem at hand, and she creates the architecture. She does an architecture. She creates it in her mind. She creates it on the spreadsheet. She communicates it. She refines it. She tries to maintain conceptual integrity. She tries to define the role of an architect. That's something that architects like doing. They like talking about what exactly is that an architect does. And they try to enable and facilitate decisions. That's another part of what they do. And in order to do that, they have a lot of things. I am not claiming by any means or any stretch of the imagination that only architects have this. That is certainly not true. But in order to be good architects, we need to have this. And some of these things are unique to us as human. For instance, an architect, I'm going to go through some of them, not through all of them. Architect has good awareness of the general versus the specific. An architect has a sense of pain. Pain, bad, failed projects are the best teachers we have. And the LLMs do not have the experience of pain. We have contextual awareness. We know how to earn and we know how to give trust. We know how to apply our knowledge and our experience to the problem at hand. That's what makes us into good architects. And architects make mistakes. They have to make mistakes. And we make tons of mistakes. We make so many decisions that it's inevitable that we will make mistakes. And when we make mistakes, if we're good at what we do, and this is not only true for architects, again, it's true for everybody, we don't defend our mistakes, we don't justify our mistakes, we learn from our mistakes, because just like pain, mistakes are the greatest teachers we have. And if an LLM doesn't make mistakes, the LLM will not learn and will not get better. If we do not make mistakes and acknowledge them, we will not learn and not get better. So, I want to talk briefly about the simplified life cycle of an architecture. It's greatly oversimplified. First of all, the architecture models. It happens in her head. It happens, she thinks about the world, she understands the domain. This happens in the shower, in the drive, wherever it happens. Then the next thing that the architect does is they make a representation of it. They do some code on the wall, on the whiteboard, on the draw.io, on the presentation, on the PowerPoint, and then they present and they argue and they defend it and they present it to somebody else, they communicate, and the ultimate output is some shared understanding. That is the simplified life cycle of an architect. And what I have found is that in the cases that I explored, it's these two areas where I'm able to do some real cool work with LLMs. On understanding the problem and articulating the solution. The actual drawing of the artifact, I have not made a significant contribution. Lots of other people do it and talk about it and do it well. So I'm going to talk in the next 2 minutes about 1 or 2 examples of using, actually I'm going to go through one example because I want to leave time for the questions. How I use LLMs in order to conceptualize and in order to analyze. Detecting ambiguities. A thing that architects have to do is detect ambiguities. Architects live in the world of ambiguity. That's what we do. We know how to live in the world of ambiguity. I'm an architect that is designing a system. The basic requirements are, the system should be able to handle a large number of users. Can you identify any ambiguities in the above requirement? And the first ambiguity I identified was large is not a meaningful word. You need something else more specific if you want to scale a system. And it also proposed that a large number of users might mean a large number of concurrent users or might mean a large number of total users. Now, when I went to a colleague and I asked her, how would you resolve this ambiguity? Her first question was, who wrote it? If you wrote it, then you should resolve the ambiguity. If somebody else wrote it, ask them to resolve the ambiguity. And when I asked the LLM, I was given the ambiguous requirement, what is a reasonable way for determining which interpretation to adopt and why? It gave me a lot of useful answers, but not the obvious one was, if you wrote it, then you have to resolve the ambiguity. What do you want from me, right? And And it gave all kinds of, it says check performance metrics, identify potential bottlenecks. This was a really weird one. Consider which interpretation presents the bigger risk for the project. If unsure, it might be wise to design the architecture to handle both scenarios to some degree. I have heard of people that would actually implement both because both might be true. I have heard that people that want to implement both in order to see which one makes more sense. But I have not often heard of people that would design two elements because the document was ambiguous. That's a very, very expensive way to resolve an ambiguity. And as humans, we would know that right away. We would know that there are much cheaper ways that you first go in order to design ambiguities. Okay, I'm not going to talk about trade-offs because we're out of time. I just want to wrap up a bit and say, LLMs can assist in reaching decisions and clarifying our thinking, but we have to ask the right questions, and we are accountable for the decision that's made. The human has to be proactive, has to enable decisions, has to consider the trade-offs, has to implement, has to understand, be specific, and has to be accountable. And accountable, like Kent Beck explained to us, doesn't necessarily mean who has to take the blame or who has to get punished or who has to suffer for the wrong decision that was done. That's not what we're looking for, right? I've heard somebody say to me, an LLM that can't experience pain can't be punished and can't be held accountable. That's not exactly what I mean. I don't need to cause suffering in order to create accountability. That's not what I'm looking for. I need the personal integrity. I need the pride in a job well done. I need to know that, and part of trust is somebody that is accountable. I'm going to end with this. One of the great stories about identity is Toy Story. I'm going to show a little brief segment here from Toy Story. Woody is a cowboy. Buzz is a toy, but he's convinced that he's a real spaceman. He believes in all sincerity that he's a real spaceman. And a lot of the tension in the movie, which is a great movie about identity, is Woody and Buzz trying to convince each other, are they real or are they just toys? I'll show you one chapter, and with that, we'll wrap up and take some questions.
You, the security of this entire universe is in jeopardy. What? What are you talking about? Right now, poised at the edge of the galaxy, Emperor Zurg has been secretly building a weapon with the destructive capacity to annihilate an entire planet. I alone have information that reveals this weapon's only weakness. And you, my friend, are responsible for delaying my rendezvous with Star Command. You are a toy! You weren't the real Buzz Lightyear, you're an action figure! You are a child's plaything! You are a sad, strange little man, and you have my pity. Farewell.
So
yeah, well, good riddance, you loony!
So that's Buzz Lightyear. The French philosopher Henry Louis Bergson says, it is then right to say that what we do depends on who we are, our identity. But it is also necessary to add that we are what we do and that we are creating ourselves continuously. It is certainly not the end. Thank you very much. And I want to take some questions. Thank you very much.